Hello guys, welcome back to our channel. By the way, I'm Judge Matthew De Leon and I will be explaining the components list and their purpose. We have 9 components such as the Arduino Uno, relay, 130 motor, resistor 220R, jumper cable fan, breadboard, mini push button, and lastly 5mm LED. First we have the Arduino Uno. It is a microcontroller board powered by the ATmega328P chip. It features multiple digital I/O pins, analog input, and supports controlling external devices through programmed logic. Its purpose is to receive input from the push button and send signal to control the relay, which powers the motor and the fan. Next, we have the relay. It is an electromechanical switch that uses low voltage signal to control higher current devices safely. It typically has pins for power, ground, input, control, and terminals for connecting an external power circuit. Its purpose is to act as an electronic switch to control power delivery to both the motor and the fan. Next, we have the 130 motor. It is a small brushed DC motor that converts electrical energy into rotational motion. Its purpose is to drive any connected mechanism or rotating element independent of the fan. Fan. It is a small DC-powered fan that produces airflow when powered. Its purpose is to provide air circulation, functioning independently of the 130 DC motor, but is controlled by the same relay switching mechanism. Next, we have the mini push button. It is a small, momentarily switch that closes the circuit only while pressed. Its purpose is to provide manual input to turn on or off the motor and the fan through the Arduino. Next is the resistor 220R. It is a current limiting component that protects connected components such as the LED from excessive current flow. Its purpose is to use with the LED to safely indicate when the motor and the fan are connected or powered on. Jumper cable It is a flexible insulated wires with metal tips for quick solderless connections. Its purpose is to connect the Arduino relay, push button, LED, motor, and lastly the fan together to form a complete circuit. 5mm LED. It is a small light emitting diode that glows when powered. Its purpose is to serve as a visual indicator showing whether the motor and the fan are running. Breadboard. It is a reusable platform with internal connections for assembling electronic circuits without soldering. Its purpose is to provide a convenient layout for connecting the push button, LED, resistor, and control wiring neatly. And that is the last of the components list. Thank you for watching our video.
Good day everyone, welcome back to our channel, and today we will be making project 13, which is motor fan. So instead of using mini button push, we will use a potentiometer. So let's get started.
potentiometer, oh sorry, we have three pins from the potentiometer, the relay pin, and the LED pin. The most important one is the potentiometer and the relay, which is for turning on and off. The relay pin is just a toggle, basically for the signal from the potentiometer, which in turns has a threshold of 700, which in turn has a threshold of 700. Okay, now the actual default state of the relay is set to low, which starts at off mode. So it always turns off, even if it is at sometimes on at other Arduino Unos. Keep that in mind. Also, I'd like to note we actually change the potentiometer from the button because the buttons none of ours worked, so we needed an alternative, so we just replaced the button to a potentiometer so it could actually work. Now it took 2 hours for us to work on that, so moving on. Sorry, moving on. Here we have the setup. As usual, we have the pin modes, the digital write, and we have the relay pin is set to high, but this ensures that the relay is off at startup. So just note that you also have to need the serial for this code, this specific code, because what we're using is a potentiometer, not a button. Now, you'd actually have to debug to find out if the potentiometer works or not. So, just a note. We actually have the final one here, and then we'll be finished. So this is the actual code we have here. It tracks the potentiometer value, which outputs to the serial monitor, and which in turn, this one is an if statement. So the other one, else if, you don't actually have to put it as an else if. You can just put it an else, because the other state is just a top. The other one, if the real estate is high, blah blah blah. If the real estate is low, it doesn't work. So anyway, if the state is high and the potentiometer is above the threshold, which is 700, and the relay state is equal to low, it will output the signal from the computer, and then in turn it will turn on the LEDs and the relay, of course. If the potentiometer value is less than or equal to the threshold and the relay state is high, it goes back to default state. It goes back to default state, meaning it reverts everything. Now, we also have a delay at the bottom here. As you can see, it's just for smooth readings, and it's just for smooth readings. It's just for smooth readings, I mean. Sorry. So that's about it. Thank you for listening, and I'll see you in the next one. So, see ya.